Welcome to the Deep Dive, the place where we take the most complex strategic roadmaps, the densest industry research, and really try to break them down into crucial, memorable knowledge for you. Today, we are strapping in for what feels like, well, a quantum leap. We're looking directly inside the strategic planning documents that are mapping out the next 15 years of the global automotive industry. And this deep dive, it isn't about new paint colors or horsepower. It's about the complete rewiring of the enterprise itself. The central nervous system that's going to design, build, sell, and service every single vehicle by 2040. We're going to be dissecting the digital and intelligent management technology roadmap, or Shuziwakwanli. It's a major strategic blueprint, and it outlines a wholesale industrial transformation. So our mission today is laser-focused. We are going to unpack the current status, outline the sweeping, almost unbelievable 2040 vision, and then walk you through the very specific milestones set for 2030, 2035, and 2040. We're pretty much reviewing the architectural plans for the factory of the future.
And this document is absolutely critical because, as the sources define it, digital and intelligent management is not just, an IT budget line item.
Right.
It is the core support system for smart manufacturing. If you think of the modern auto enterprise as this massive, complex organism, a tech company that happens to make cars, then this system is the brain. It's the central nervous system coordinating every single function. The whole strategic roadmap is built on three foundational pillars. And these are what dictate where billions in investment will flow over the next decade and a half. These are really the anchors of the transformation. First up is R&D PSS synergy.
That is a mouthful.
It is, yeah. It stands for research, development, production, supply, sales, and service. This pillar, it demands full chain collaborative management. So it means zero tolerance for those traditional organizational silos that separate, the design team from the supply chain team, or service feedback from R&D.
So breaking down those walls is the first step. What's the second?
The second is data sharing and security. In an era where every vehicle, every process is hyper-connected, data has to flow freely and it has to flow quickly. But, and this is a big but, that flow has to be secure, trustworthy, and compliant across all these different jurisdictions. This pillar treats data flow not as some logistical challenge, but as a core competitive advantage that has to be fiercely protected, both internally and externally.
And the third pillar, this sounds like the real revolution in management, is data plus AI empowerment.
It is.
This is where the subjective human judgment of the past, gives way to calculated optimization. It's about using AI, big data, advanced algorithms, not just to assist managers, but to fundamentally reshape decision-making across the whole company, and often to do it autonomously.
Synergy, data, and AI. Those are the three engines driving this whole quantum leap.
Okay, let's unpack this idea of necessity. Why now? Why is this transition to, fully intelligent management mandatory for survival? The sources are pretty clear that this moves the industry way beyond simple efficiency gains, which were the traditional focus of IT spending, toward a wholesale transformation. This new identity is intelligent, it's networked, and it's fundamentally service-oriented.
Yeah, we're really past the point of just polishing the status quo. We are talking about an existential transformation. The sources identify 4 key competitive advantages that successful digital management provides, and they really illustrate why delaying this shift is just not an option anymore for auto manufacturers who want to thrive by 2040. The first, and maybe the most powerful advantage, is full chain data flow, creating a demand-driven closed loop.
Okay.
Traditionally, if a customer complained about a feature, that feedback would take months, maybe even years to filter back to the design team for the next model.
If it got there at all.
Right, if it got there at all. Now, digital management builds this closed-loop system where user demand is injected directly into product definition. Service feedback instantly optimizes future R&D. It completely flips the entire process, moving from a producer-pushed linear model to a demand-driven, data-enabled ecosystem.
So feedback isn't some annual review anymore. It's a real-time system calibration.
Yeah.
That level of speed sounds like it would require just immense internal coherence.
Exactly. Which brings us right to the second advantage. Platform synergy, activating continuous innovation. The mechanism here is what they call the industrial internet platform.
Right.
This is the organizational and technical bedrock that lets you have seamless, real-time data sharing across design, production, sales, all of it. It's not just about sharing a document, it's about having a common language and real-time feedback mechanisms that just dramatically accelerate the innovation cycle. Innovation becomes a constant automated function of the system, just perpetually iterating on product and service quality.
The third advantage deals directly with gaining market initiative. Intelligent decision upgrades. I love this concept because it directly addresses, human fallibility in big organizations. Instead of managers relying on historical experience or gut feeling or what worked last quarter, the enterprise build an AI decision hub.
This is so crucial. The hub integrates these vast amounts of multi-source data to create smart systems for precise demand forecasting, optimized capacity planning, and maybe most critically, quality pre-warning.
So it's spotting problems before they happen.
Exactly. It completely replaces subjective, experience-based management with objective data modeling. By running real-time simulations and optimizations, the enterprise can accurately grasp the immediate pulse of the market and adjust its operational strategies flexibly. It lets them control the market initiative rather than just reacting to it.
And finally, the fourth point ensures survival in what's an increasingly volatile world. Building a resilient system. I mean, if the last few years have taught us anything, it's that supply chains are fragile.
They're incredibly fragile. The sources really emphasize the need for a global smart risk warning system.
So what does that look like?
Well, this system models multidimensional data, so geopolitical risks, logistical data, weather patterns, material prices, all of it. It models this data to proactively identify potential risks, whether that's a looming supply chain disruption or the impending failure of a critical piece of factory equipment. This just fundamentally enhances supply chain resilience. It allows for immediate resource allocation shifts, and it strengthens the company's ability to withstand these complex external environments. It shifts the entire risk posture from reaction to preemption.
So if that's the strategic necessity, agility, responsiveness, resilience, how do companies actually make this massive transformation happen? The sources identify 5 key elements that need this holistic top-down integration. This is kind of the internal checklist for success.
The first element is the North Star. Value creation. You don't measure success by how many servers you buy. You measure it by sustained business growth, increased efficiency, profitability, and of course, enhanced customer satisfaction. The transformation has to deliver tangible business value.
Right. It can't just be tech for tech's sake. The second element is vision blueprint, which, in more conversational terms, is the absolute necessity of a top-down master plan.
Absolutely. It means clearly defining the strategic direction, the technical implementation path, and securing the necessary resource guarantees from the board level all the way down. This makes sure the transformation is systematic, forward-looking, and most importantly, executable across all divisions at the same time.
Third is business restructuring. And this isn't just shuffling names on an org chart, right?
Not at all. It means fundamentally rethinking the customer experience, overhauling operating models, and reinventing management methods. You leverage digital technology to optimize every single process, elevate service quality, and develop new digital products and services that monetize data.
And none of that works without the fourth element, which is digital capabilities. This is the technical muscle.
It is. It requires building a unified database, a common data language, and a cloud-based digital platform to support all the new AI, IoT, and 5G technologies. This provides the technical driving force that prevents new systems from just becoming new silos.
Finally, we address the human element. Transformation safeguards. This is all about the organizational and talent side.
Yeah, and it's so often overlooked. It requires structural reform to create an organizational structure that's adaptable to intelligent management, ditching the old hierarchies. And critically, it means investing in cultivating or acquiring the necessary digital talent. Without training and reform, the technology just sits there unused, and the whole transition fails.
That sets the internal stage. Now we need to know where the industry actually stands. The sources give us this fascinating global comparison, noting that domestic, primarily Chinese, and international auto enterprises have chosen really distinct strategic entry points for their digital transformation. It seems like 2 different races are being run at the same time.
They are, and the starting lines are very different. When we look at domestic auto enterprises, their core breakthrough strategy really centers around the C2M mode customer to manufacturer.
C2M.
Right. They leverage cloud-native infrastructure, IoT, and AI to get this precise real-time match between volatile market demand and their production resources. Their internal strategic focus is heavily on IT and OT data fusion, so fusing information technology data like ERP and sales with operational technology data, which is the actual robots and sensors on the factory floor.
And on the other hand, international auto enterprises have approached this with a primary focus on data ecosystem construction.
Exactly. They prioritize ecosystem openness and deeper data collaboration across corporate boundaries. They are the ones leading the charge in establishing these massive cross-enterprise, standardized data sharing consortia, things like Catena X in Europe or other large open platforms. They're trying to set international data standards from the get-go, enabling secure data exchange across the vast global supply chain.
So one is focused inward, on fusing its own data, while the others focus outward on building the pipes between companies.
That's a great way to put it. And we see a similar distinction in AI application. International firms are typically integrating large AI models deeply across the entire value chain R&D, production, service from the very beginning. Domestic efforts, while making huge strides, initially prioritize those high-impact areas like the smart cockpit experience and autonomous driving features where the consumer-facing value is most immediate.
This C2M model feels like the true heart of the transformation. I want to spend a moment on the profound shift in manufacturing this enables. We really need to contrast the old production by inventory model with C2M because the metric cited in the source is just stunning.
It really is. The traditional model was defined by linearity. High cycle times, high costs, high inventory, and very limited customization. You, the consumer, you picked from a finite set of options. A standard car model might offer maybe 200 possible configurations.
200 choices. That sounds manageable.
It is. But the C2M model is production by order, and it demands these high levels of real-time collaborative management across design, sales, supply, production resources. And this flexibility is critical for new energy vehicles. The source states that new energy vehicles supporting customized configuration can reach upwards of 7,000 types of optional configurations.
7,000.
7,000. Think about that. That's a 35-fold increase in complexity. It's the difference between a simple menu and a massive bespoke catering operation that changes every single minute. The traditional management system based on fixed production runs, it just breaks under that kind of complexity.
How does the system even begin to manage the inventory and supply chain for that level of variation? I mean, tracking 7,000 different seat materials, infotainment systems, battery packs, wheel options in real time? It seems impossible.
And that's the strategic necessity of this digital and intelligent management system. The C2M model shifts production from mass production of standardized items to mass customization of small, highly varied batches. This requires real-time synchronization. Inventory management, for example, changes from twice a day to 20 times a day. Quality management shifts from post-event reaction, checking the car after it's built, to preemptive warning, where AI anticipates a potential defect based on real-time sensor data from the welding robot. The only way to handle 7,000 configurations is through total digital coordination.
That complexity really drives the need for a measurement framework. To track progress toward 2040, the sources introduced the Intelligent Manufacturing Maturity Model, or IMM. This is the strategic assessment framework, and it's built on an evolutionary path. Digitalization, then networking, then intelligence, and finally, self-evolution.
Let's use this model to chart the path, starting from the ground up. IMM1 is single-point digitalization. This is the starting line for companies still using siloed systems. The focus is on initial infrastructure building and achieving data sharing, but only within single business domains. So the R&D department talks to itself, but not to production.
And decision-making is pretty basic.
Right. It's supported mainly through data visualization. You're essentially turning paper reports into digital dashboards. The goal is localized optimization, not enterprise-wide change.
Okay, so moving to IMM2, networked collaboration. This is the platform stage. The enterprise shifts from these dispersed digital capabilities to an integrated, platformized operational model. Data must now flow across departments.
For management, companies begin to build detailed knowledge graphs. Think of it like a structured digital Wikipedia for the company's operations to support decision-making. The whole goal is to break internal information silos and enhance coordination efficiency.
Next is IMM3, intelligent decision-making. This sounds like a significant functional leap.
It's a huge leap. Data flows seamlessly, internal data is fully shared, and crucially, the enterprise has effective external data partnerships. They can now deeply extract value to precisely match production resources with those 7,000 market demands we talked about. Management utilizes specialized vertical industry knowledge graphs and advanced predictive models to achieve a fully automated closed-loop intelligent management system.
And the summit of this maturity model is IMM4, ecosystem self-evolution. This is the highest, most adaptive form of intelligent management.
Yeah, this is the end game. Data is fully interconnected, both internally and externally. The enterprise becomes an active participant in industry data spaces, and the entire system is capable of continuous self-iteration and optimization without human intervention in daily operations.
Wow. This final stage is defined by deep integration with cross-border partners, tech firms, energy grids, city infrastructure to realize a coordinated vehicle road cloud city system. It means your car, the traffic grid, the power station, and the manufacturer are all communicating in real time to optimize mobility, energy consumption, and production scheduling.
That maturity model gives us the evolutionary steps, but now let's look forward to the ultimate destination. Part 3 defines the 2040 vision, which centers on a fundamental identity shift for the entire industry.
Yes, the ultimate vision for the next 15 years is the industry-wide creation of a self-adaptive, digital, and intelligent ecosystem. The whole enterprise identity fundamentally shifts from being manufacturing-driven to digital intelligence-driven. And this future state is built on 4 core components. First, secure fusion and sharing. This means data sources are no longer just confined to internal systems. They leverage data trading and deep industry cooperation securely and compliantly to achieve a rich, comprehensive data foundation for management and decision-making. Data becomes a liquid asset. Second, and this is the revolution in governance, objective management. The management model transitions from being subjective and human-centric to being entirely data-centric and objective.
Right. All organizational knowledge, hard-won experience, best practices, it all gets codified and stored in models and data. It's not confined to the heads of key personnel who might leave the company. This digital codification prevents capability loss and solidifies best practices globally.
And third is the technical engine, self-evolving models.
Technology moves way past simple prediction. Enterprises will leverage cutting-edge algorithms, neural networks, deep learning to construct management decision models that are self-learning and self-evolving. The system performs real-time calculations and continuous optimization on its own, making micro-adjustments faster than any human team ever could.
And fourth, the resultant organizational efficiency, transparent communication.
When everyone uses a unified, single data language that the system itself manages and enforces, communication becomes highly efficient and transparent. The system actively assists in resolving departmental differences based on objective data inputs, which eliminates ambiguity and organizational friction.
So to make this vision concrete, the roadmap sets highly specific, quantitative targets for each milestone. This isn't just theory. It's a measurable action plan that companies are expected to hit.
It is. Let's walk through the evolution of efficiency, starting with synergy, R&D PSS, which is the measure of collaborative speed.
By 2030, the goal is to establish a preliminary framework and achieve local optima in collaboration. The full chain response cycle is measured in weeks, so a major design change or supply issue resolution takes a few weeks.
By 2035, the system reaches basic maturity and dynamic optimization, and that shrinks the response cycle to weekly.
But the goal for 2040 is industry leadership, achieving a response cycle of just days.
Days. The sources call this the ecological autonomy state, moving the response time for the entire value chain from an initial R&D change to factory implementation from multiple weeks down to just days is a monumental shift. It fundamentally changes the innovation velocity of the whole enterprise.
Next, let's look at the nervous system itself, data sharing rate across the enterprise and supply chain.
In 2030, the target is 30% sharing, focusing mostly on internal unification and just initial supply chain integration. By 2035, this leaps to 70%, driven by deep integration across the full supply chain and multi-factory operations.
And by 2040, the goal is near 100% unification and sharing.
And this isn't just internal. It establishes the enterprise as an industry benchmark for cross-border and multi-factory data collaboration. If you have production facilities in 3 different countries, the data has to flow as if they were in the same room.
The third metric is AI decision coverage, which shows how deeply AI has penetrated management. In 2030, AI should cover 30% of initial scenarios, using small-scale AI tools for specific tasks.
By 2035, coverage expands to 50% across the full R&D PSS chain, leading to comprehensive management intelligence.
And by 2040, AI must cover over 80% of decision scenarios, achieving precise forecasting and real-time system decisions. We think about that for a second. 8 out of 10 decisions affecting the business are being calculated and executed by an autonomous system. That completely redefines the role of human management.
Completely. And finally, the shift in revenue focus is measured by the business model conversion rate, In 2030, the goal is a 30% pilot implementation of new models, focusing on user profiles and subscription services, the start of car as a service.
This evolves to 50% conversion by 2035, deepening that new automotive model.
And the ultimate target for 2040 is 70% conversion. This signifies a thoroughly optimized innovation system where service revenue is explicitly projected to exceed 50% of total revenue. That is maybe the most profound quantitative target in the whole roadmap. It proves that by 2040, the auto company is fundamentally a service platform that just happens to manage mobile hardware.
Okay, so these quantitative goals are underpinned by highly detailed technical blueprints. This final section dives into the specifics. The how by charting the evolution of the three core pillars across 4 dimensions: technology, process, system, and ecosystem.
Let's start with that first pillar, R&D, PSS, synergy, and ecosystem construction. How do you move from siloed departments to this seamless, days-long coordination?
The 2030 focus is preliminary connection, IMM 12.
Right. The technology focus is foundational integration. The goal is for 50% of large enterprises to establish industrial internet platforms. They must apply key technologies like digital twin, 5G, AI, and cloud across the entire R&D PSSS chain. And crucially, they begin building enterprise-level large models for design and supply chain, leveraging something called model-based systems engineering, or MBSE.
Wait, can you quickly unpack MBSE? That sounds like classic management jargon.
It is, but the concept is simple and revolutionary. Instead of designing the engine, then the chassis, then the software separately and just hoping they fit together.
The old throw-it-over-the-wall method.
Exactly. MBSE forces you to design the entire complex system, the vehicle, its manufacturing process, and its service requirements, all at the same time using integrated models. You're designing the product and the factory and the maintenance schedule all at once, ensuring perfect synergy from the drawing board.
Got it. So 2030 means achieving initial digitalization and flow-through, establishing an integrated operation system, and connecting products, production, and services in a preliminary way.
Then you move to 2035, high automation and intelligence, IMM 23. Technology scales rapidly. Enterprise big data platforms drive full integration across the value chain. 80% of large enterprises must build enterprise-level internet platforms. The big leap here is the co-building of industry-wide large models, shared AI models by supply chain partners. This enables all-domain search and traceability for every single component.
So AI matures to handle predictive decision-making across the whole chain.
It does. Process-wise, this means highly automated flows and a user-centric network architecture. The ecosystem scales to an intelligent, networked industrial ecosystem circle.
Finally, the 2040 focus. Super intelligent ecosystem, IMM 34.
The technology platform achieves its final form, a pan-connected industrial big data platform, shifting to data co-creation and sharing across partner ecosystems. The head enterprises must build ecosystem-level internet platforms. Their enterprise large models are now fully merged with industry large models for ecosystem chain collaborative design.
And the ultimate 2040 ecosystem vision is this total integration. Auto manufacturers achieve cross-border integration with tech firms, energy suppliers, research institutions to form a super intelligent grand ecosystem, making that vehicle road cloud city coordination an everyday reality.
Your car is coordinating traffic signals and power consumption with the city grid in real time.
Now let's pivot to the second pillar, data sharing and security. None of that coordination works without trusted, compliant data flow. And this has to be a massive headache given the rise of global regulations like GDPR.
It's a huge challenge. The 2030 focus is enterprise-level governance. Technologically, the first step is data lakehouse integration for unified data storage. Think of it as merging the messy, raw storage of a data lake with the structured quality control of a data warehouse. This unified system has to ingest data from industrial devices connected via pervasive sensors. And crucially, the enterprise must establish unified internal data classification standards, labeling everything from security critical to private to commercial secret.
So systemically, they're building the enterprise data governance system and hiring specialized data security and compliance people. The goal is unifying 30% of internal data, exploring initial cross-chain data flow, and establishing the preliminary ability to defend against threats like ransomware.
Then for 2035, the focus shifts to industrial chain interconnection. The data architecture refines, using distributed storage for deeper value extraction. Internally, data is fully classified and protected based on metadata. The critical technical leap here is the mature use of privacy computing.
Privacy computing, that sounds like science fiction. Can you give us an accessible analogy for that?
Yeah, absolutely. It's the ability to collaborate without revealing secrets. Privacy computing uses techniques like homomorphic encryption or federated learning to ensure sensitive data is usable but invisible during cross-enterprise analysis.
Usable but invisible.
Right. So imagine two competing auto suppliers. They want to calculate the combined risk in their shared raw material supply chain. Privacy computing lets them run the calculation on the combined dataset and get the aggregate result without either one ever seeing the raw proprietary numbers of the other.
That makes the industry-wide collaboration suddenly possible.
Exactly. Process-wise, this means establishing industry data standards and building cross-enterprise sharing platforms. Blockchain is introduced to ensure data segregation and exchange management across enterprises, guaranteeing anti-tampering properties.
And the goal is 70% internal data unified, 30% cross-chain flow. The security system also transitions from passive reaction to active defense based on real-time risk posture awareness.
Finally, 2040 targets the cross-industry data space. Technologically, the architecture is mature, allowing full element flat interconnection across the entire value chain. Global operations mean meeting stringent global and regional compliance requirements like GDPR is mandatory. Advanced security technologies, maybe even things like quantum encryption, are adopted to future-proof these massive data systems against advanced threats.
And process-wise?
Process-wise, this means establishing cross-industry data standards and building platforms that allow data sharing across sectors: automotive, energy, transportation, smart city. The system forms an automotive industry data circulation and security association to govern the flow. The ultimate goal is 100% internal data unification, 50% cross-chain data flow, and the creation of an industry-trusted data space where data security incidents are near zero.
This is the part that feels the most revolutionary. How AI fundamentally alters the nature of management, transitioning us from human experience to system-calculated governance.
It's a huge shift. Let's start with 2030. Parameter models and AI agent introduction. The starting technology involves codifying human experience, literally writing down the best practices and organizational knowledge to build initial simulation models. This covers about 30% of decision scenarios. A unified AI platform is built, starting with small-scale AI applications. But the game changer here is the introduction of AI agents.
What exactly is an AI agent in this context? Is it a robot?
Not a physical robot, no. It's an autonomous piece of software designed to perform complex, goal-oriented tasks. These agents begin optimizing algorithms and handling detailed, standardized tasks, things like inventory reordering, machine scheduling, or drafting initial design proposals. This immediately leads to a projected 30% reduction in manual workload for humans.
The resulting process is a hybrid decision-making model, human brainstorming paired with AI simulation and inference. Systematically, the organizational change begins. Organizational flattening starts, moving towards a platform plus team agile model, where managers shift their focus entirely to setting strategic rules and ethical supervision, not routine oversight.
Then you move to 2035, automated predictive models and full chain expansion. Technology evolves to supervise machine learning models that can predict overall business conditions, covering 50% of decision scenarios. The AI platform expands to cover the full R&D PSS chain. Large multimodal models achieve scaled application.
And the AI agents?
The AI agents fully integrate into core processes. They handle high-level tasks like supply chain optimization and production control, reducing manual workload by another 20%. The remaining labor force structurally shifts toward AI training and ethical supervision roles.
So 70% of daily operation decisions are handled autonomously by AI. Managers are now primarily supervisors of the system, not operators of the process.
And the ultimate target is 2040. Self-evolving intelligent decision models. Technologically, the enterprise builds self-learning, self-evolving models, covering over 80% of decision scenarios. The AI agents become the central nervous system of management. The source even mentions integrating concepts like brain-computer interface and digital twin for human-machine collaboration.
Wait, BCI. Are we talking about managers literally connecting their thoughts to the enterprise AI by 2040? That sounds like pure science fiction. What does the roadmap mean by collaboration here?
It's definitely futuristic, but the context is practical application in complex systems. It refers to advanced human-machine interfaces that allow for intuitive, real-time interaction with the digital twin models of the enterprise. Think of it less as a plug in your head and more as a seamless, high-bandwidth connection where a manager can instantly visualize, simulate, and adjust complex systems like manipulating the full factory digital twin using advanced inputs. It reserves their cognitive energy for strategic and ethical exceptions.
That helps ground it. So the resulting process shift is profound. The mechanism moves to automatic decision plus human review. AI agents complete the full closed loop.
And organizationally, the traditional hierarchy just disappears entirely. The structure is hierarchyless and networked. Traditional departments vanish. Employees act as flexible nodes, moving between projects based on AI-determined needs. The goal is achieved. Management decision calculations are generated by the system in real time, and human managers are solely responsible for reviewing and supervising the results and setting strategic rules.
This roadmap is not just about adopting new technology. It is a full-scale corporate metamorphosis that redefines the relationship between technology, data, and human labor. We've charted the course from foundational data governance in 2030 through deep enterprise integration in 2035, all the way to a self-evolving cross-industry ecosystem driven entirely by autonomous AI agents in 2040.
The scale of this transformation means the industry itself fundamentally changes its identity. We really see three core transformations driven by this roadmap, solidifying the industry's ultimate identity change.
The first change is shifting the relationship with the customer, from product-centric to user-centric. The industry moves away from selling standardized vehicles toward providing personalized, highly profitable, subscription-based mobile services, the core of car as a service. That target of service income exceeding 50% by 2040 is the ultimate proof of this business model shift.
The second is the industrial restructure. From linear value chain to network ecosystem, the rigid fixed hierarchy, or the OEM-commanded Tier 1 suppliers, is replaced by a dynamic, flexible network. This ecosystem integrates technology, energy, and urban infrastructure, realizing that vast vehicle road cloud city coordinated system. By 2040, competition is solely between rival digital ecosystems, not individual car brands.
And the third, the most radical internal change. From experience-driven to data-driven, with AI decision coverage exceeding 80%, management decisions are system calculated in real time for a global optimal. The manager's job shifts from being a subjective decision-maker to becoming a strategic rule-maker and the ethical supervisor of an autonomous system.
This transformation really suggests that the future competitive battlefield won't be manufacturing efficiency, which will be optimized by AI systems across the board. It will be about who owns, governs, and securely manages the resulting industry data space.
So our final thought for you to consider is this. In this hyper-connected car-as-a-service ecosystem of 2040, where vehicle uptime is guaranteed, every route is optimized, and every decision is logged, what specific data points, beyond just location and purchase history, do you think will become the most valuable and the most fiercely protected asset for the new intelligent mobility operators who are running the entire system? That's it for this deep dive. We'll see you next time.